Welcome back. In the previous video, we have seen how we can make basic adaptations to our model to suit our case study. In this video, we look at the actual input and output files that the SWAT plus executable reads and writes. We can edit the inputs right from the txt_out directory, as I will show you, but be careful when you write your files in SWAT plus editor after that, because you might overwrite the changes that you have made. The good thing is SWAT plus editor gives you a warning about this. Now, which files are we going to look at? There are many files that we can look at. In this video, we will focus on time.sim, print.brt, channel SD, and time step, which can be day, month, year, or annual average. Basin water balance file. We also look at HRU data, Landuse management, plant community files, management schedules. We'll also look at connection files and decision table files. You can find these files in txt_in_out directory. If you go to SWAT plus editor, you can copy the path to your directory and paste it in the address bar. You can use Ctrl+C, or you can just go where you have your model and open the file from there. But we will navigate through the project files just so we can see the file structure. Our model is in desktop, Robert. If you open the project directory, you will see 2 or 3 folders and a number of files. The first folder is for backups. When SWAT plus editor operates on the database, it keeps a backup just in case something goes wrong. Then you can always go back to this database contained in this folder. You also have the scenarios directory. This is where we have our scenarios. And for now, we only have the default scenarios as we have seen in the previous videos. Scenarios. You can recall this file from part 3, where we have our simulated and observed time series. Our scenario files are inside the default, where we have the results or the plots from the visualization and animations, and also the txt_in_out folder. We also have the watershed directory, which contains rasters and shapefiles that are used during the model setup. If we open it, we see we have rasters directory where we have the DEM, landscape. If you generated flat planes, you find them there. You have Landuse, so it's just the Landuse map, and the soil map. If we go back, then we find shapes. If you open that, you can see the HRU shapefile if you clicked to generate it. So you have the potential HRUs and the final HRUs, and you also have the landscape units shapefiles, and then the outlet files and reservoirs if you have reservoirs, and the reefs shapefile, which are the streams that are generated, and so many more down here. Let's go back. And here you have text files which include reports. So you have HRU reports and the others. Let's go back. Here is the project file for SWAT plus editor, and this is the QGIS project file, and you have the project database which contains all the information related to our project, and you have the SWAT plus datasets database which contains the default parameters and tables used by SWAT plus editor. Let's go into our txt_in_out folder and look at a few files. Scenarios, default, txt_in_out folder. So the first file that we look up is the time.sim file. So we will just use search to find this file. Here is the file. This file is used to define when you start running your model and when you stop running the model. You can open any of these files using a text editor such as Notepad++, the regular Notepad, or Visual Studio Code. Right click, open with, more applications, Notepad. Make sure that you have checked this checkbox if you want to just double click in the future to open the files. Okay. As you can see, it gives you the day that the simulation starts, the year that the simulation starts, the day that the simulation ends, the year that the simulation ends, and the timestamp code. Another file we will look at is print.prt. This file helps you set up the warm-up period and also helps you choose which output you want to print and for which time steps. Let's look for it. So if we right click and open with Notepad again, check so that in the future you can always use Notepad. Okay, so this is the warm-up period. You can set up the day you want to start printing and the year, and also the end, year end, and the interval you want to print. You can also set to print CSV output, and to enable CSV output you use Y. I'm going to save that. These are the tables that are found inside SWAT Plus editor, and for each one of these you can select to have daily results, monthly results, yearly results, and annual average results, just as you could do it inside the SWAT Plus editor. For instance, if I no longer want to have HRU water balance results for annual average, I could just remove this Y and put N in it. Remember to always save the files when you make changes. Close. Let us also take a look at connection files. Connection files show connections between objects within the model. It could be channels or aquifers or any other object. These files have the extension .con, and you can easily search for connection files by typing .con. .con. We will look at Chanteg. So I will do the search. Right click, open with Notepad. So Chanteg.con files show connections between channels. The column out dot, this one, fifth from the last, shows the number of objects that the channel is routing flow into. For instance, channel 1 is routing flow into channel 22, and channel 2 is routing flow into channel 1. Channel 3 goes into channel 2, and so on and so forth. You can have flow going from one channel into two channels. Let me give an example. For instance, if you want flow from the 10th channel going into two different channels, then you have to change the number of objects. It was 1 because it was only flowing into 1, but now it's going to be 2. And you will have the first object, 22, and what's the percentage of the flow flowing into 22? Right now it's 100%. Maybe you want it to be 50%, so 0.5. And then you have to repeat this. Copy. And you type in a different channel that you want to send the remaining 50%. Be careful when you do this, because it is possible to send 100% of the flow from one channel to both channels. That way, you will mess up the entire water balance of your model. Note that you can also do this within SWAT Plus editor. Let me show you quickly. And channels, and edit channel. So channel 1 is flowing into channel 22, and you can change here. Say you are sending flow to channel 22. You can use another into which the flow flows. You can also send the outflow to multiple channels by adding another channel like this. So you send total hydrograph, order 2, which channel do you want to send to? The 3, and what fraction you want to send there? Let's say 0.3, and save changes. Make sure that this is 0.7, so you have a total of 100%. Always remember, if you make changes within SWAT Plus editor, you will have to rewrite the files if you want your changes to be reflected in the results. Let's go back. Going back to the chandeg.conf file, we'll see that almost every channel is flowing into another channel, just one other channel. But if you scroll down, you will notice in your list, one of them is not flowing into any channel, at least one of them. And if you go down, the rest flowing into one channel. What this means is that this channel is flowing into a sink. This means that this is the main outlet for your watershed. Thus, the model does not go beyond this point in space. So, for small catchments, you can always open the chandeg.conf file to check which channel is the main outlet in your watershed. In our case, as we have seen in previous videos, it's channel 53. Let's close that. Let's also look at a few output files. To begin with, channel SD and time step, which could be month, day, year, or annual average, as I said earlier. This file shows mass balance in each channel for specified time step. This includes water balance, nutrient balance, and sediments. Let's look for one of these files, channel SD. In this case, we have channel SD month. Open that. Maximize it. So this file has headers here to guide you what each column is all about. Firstly, here you have the Julian day. If it's daily, it's from 1 to 365 or 366, depending on whether it's a leap year. And you have day, year, and unit. In this case, unit can be taken as the channel number. You can also use GIS ID as the channel number. Or the channel name will also give you a hint of what's the channel number. For instance, this is channel number 7. Yeah, this tells you it's channel 7. And yet again, this tells you that this is channel number 7. Here you have area in hectares. And you have the precipitation in hectometers. Notice the units on top here. This means if you want to check your precipitation depth, you will have to convert into millimeters. You have evapotranspiration, seepage, and so on. If you go further to the right, you find nutrients and sediments, and also you can find the column which deals with the flow. From this column, you can extract your hydrograph if you want to make plots in Excel. We will look into that when we do evaluation. Another interesting output file is the Basin water balance, and you have of course different time steps for this, but the most interesting one is the annual average one. Let's open that. Basin water balance annual average. Open that. This one gives you a summary of the water balance for the entire catchment. This is important in checking potential problems with the model. For instance, you can check if you have too much surface runoff, or maybe too much lateral flow, or water yield, or percolation, evapotranspiration, or any of the other components of the water balance. You can also check the average curve number, which in this case looks too high. You have all the other columns as well, which you can totally check. Potential evapotranspiration, irrigation amount, and so on. From here, the files that we want to look into hrudata.hru, landuse.lum, plant.ini, and management.sch are important in order to understand the land use, crop, and management practices in the watershed. Let's start with hrudata.hru. So press H, hrudata.hru, there we go. Open with Notepad. Okay, so this file contains a list of all HRUs and their properties, such as soil and land use management and the land use management codes, for instance, agriculture, land use management, as we can see here. And this is also the file that is used to make connections to wetlands using the surface storage column right here. But we will focus on the land use management column and keep in mind these codes. Close. Another file is landuse.lum, and this is connected to the hrudata.hru, as I have said. Landuse.lum. Okay, so these are the names that you found inside the hrudata.hru, and this file gives more details or more information on the land use management practices assigned to each HRU in the hrudata.hru. For now, don't worry about calibration groups, but look at this column which has plant communities. And this is what we're going to discuss next. You also have management schedules column, which we will discuss after the plant communities. Other than that, you have the column that defines the curve number. So in another table, of course, each one of these has curve numbers. And you have conservation practices. For now, let's go to plant communities first and then to the management schedules. Plant communities are listed in a file called plant.ini. So plant.ini. So these are the plant community names from landuse.lum. A plant community comprises of plants that grow together in the same area, in this case in the same HRU. This file also has the state of each of the listed plants at the beginning of the simulation. This file, along with management schedules, can be used to specify mixed cropping and crop rotations. If you want to add another plant to agricultural community, you can add it here following the same format, but that means you have to change the plant count to 2. For instance, I can say 2, and then I will just copy this to make it simple. And there you go. And then change the name of this plant to something like corn. And then here we can have tomatoes. Be sure to specify the correct values for land cover status, leaf area index, initial biomass, and so on. Close. And now let's look at management.sch. Management.sch shows a sequence of operations for each schedule. The operations are either listed in the file or reference to land use management decision table. So in this case, we have one automatic operation, which is planting and harvesting for agriculture. So I will summarize what is happening in the previous 4 files again. First, You have your HRUs in these files with all the properties, but you also have the land use management column, which specifies the land use management practice that is taking place in that HRU. And to know more about this land use management practice, you go to the land use LUM, where you find a corresponding name that is listed in the HRUs. And you have, for each of these land use management practice, the plant community that is growing in there. So this is just a name, not the actual plants. If you want to find the actual plants growing in there, you have to go to the plant.ini, where you have, for instance, forest_com. So you have forest_com here, and it tells you that you have only forest growing in here. And for agriculture, you have tomato and corn. We have changed this, as you remember. And how are these crops managed? How are they scheduled? To find that, you go back to the landuse.lum to the management column, and then it will tell you, for now, you don't have any management taking place for that. But for agriculture, we see that you have AGRL rot. So what is this AGRL_rot? You have to go to the management schedule, which will show a sequence of activities for each of the land use management practice. In this case, you only have one automatic operation, which means the planting and harvest in this case is decided upon meeting certain conditions. To understand how this is achieved, meeting all these conditions, we'll have to discuss decision tables, and that's what we will do next. Remember that you can also schedule directly operations, but you have to mention the number of operations that are listed. So you provide the month, the day, or if you are using heat unit scheduling, you provide the number of heat units, and then you go ahead and fill the operation data in the rest of the columns. Before we go into decision tables, I want to show this kind of connection inside SWAT Plus editor. So go to SWAT Plus editor, land use management. So we have land use management section. These are the land use management practices that can be referenced to from each HRU. And for each of these land use management, you have a plant community and a management schedule. So agriculture plant community, click on that. You see you have agriculture growing here. Not that in our files we have tomato and corn because we changed that, but that cannot be reflected in the database because information comes from the database to the text files. Okay, so I'm going back. For the schedules, we can click here and we'll see you have one automatic schedule, and as I demonstrated in a previous video, you can add an operation using this button. Okay, and then we go back. I mentioned something on curve numbers in landuse.lum, and here is where you can find more information on what the actual values are, and you can change them. I also mentioned something on the conservation practices. You have cross slope, up, down slope, and you can change these, and SWAT Plus editor will autocomplete for you. If you want to see all the conservation practices that are available, you can click on this table, conservation practices, and here are the ones that are listed. All right, I hope you have seen the connection between the HRU file, the landuse.lum file, the plant community file, plant.ini, and the management.sch file. Now we will go to decision tables. Decision tables end in .dtl. This is an example of a decision table, but this one is for land use management. Let's open it. In this decision tables file, we have 21 tables, and for each of the tables you get a name and the number of conditions. So in this case, this is PLHV WWHT. You can deduce that is plant and harvest for wheat. Conditions, you have 6 conditions, and you have 4 alternatives and 3 acts that can be applied. For simplicity, we'll have a smaller decision table which we can use to discuss how the decision tables work. Close. In this table, there is a list of actions that take place when specific conditions are met. As you can imagine, this gives the user more flexibility when timing different operations within the model. For example, reservoir operations. In this table, we have two conditions. This is the first condition, and this is the second condition. And we have one alternative here, and we have one act. So to better understand this, think of it as having 4 quadrants as shown here. So you have in the first quadrant conditions, and then alternatives, and action entries, and then the actual actions. So quadrant 1 contains conditions, which is basically a list of variables, objects, and specified limits. So if you are looking at the first condition, this one, you can break it down like this. Soil water is the variable, and HRU 0 the object. 0 means current HRU, so it could be any HRU unless you specify other number other than 0. And then this part, which is here, is the limit. As such, you can read this condition as if the soil water in the current HRU is, then you have some form of inequality or equality here, and then you say this limit, food capacity fraction multiplied by 0.9 or 90% of the food capacity. But you see, this condition is not complete without alternatives. So quadrant 2 gives you the alternatives. This can be less than, more than, or equal to. Okay, so if we add the less than sign, this one, into our sentence, the condition now reads, if the soil water in current HRU is less than the limit. Quadrant 3 shows which conditions are performed when the condition is satisfied. So if you have Y, it means when these alternatives, alternative 1 is satisfied, which means these conditions are both true, then the action here, which is harvest and kill in quadrant 4, gets performed on these objects. So in your case, in our case, it's HRU 0. So you harvest and kill in the current HRU, and what do you harvest? Grain. In case one of your conditions should not be considered, then you have a dash, then the activity is only performed if the specified condition is true. With this knowledge, you can make changes to decision tables. You can also make changes to all the other files that we have discussed in this video. Now, after you have made changes, you can come straight to SWAT Plus editor. You can go straight to SWAT Plus editor and go to the run model section and run your model again. But sometimes you might only have the txt out directory, and to run your model in this case without having a project in SWAT Plus editor, you will need to go to the SWAT Plus website, and when you click on download SWAT Plus, down there you find executables. So we'll download these executables, save, I will open, and then I will copy the executables to my project txt out folder, paste. So here are my executables. you can just double click on any of these. So this is the release and this is the debug. You first of all try the release. If something goes wrong, then you use the debug version. So we see my model is running. And it's done. If your window suddenly closes as soon as you double click the executable, you might want to open a window, command prompt window from here, type cmd, enter, and then run your model by typing rev, and then you can autocomplete by using tab. So this is the debug. Press tab again, release, to run with the release version, or with the debug, then it will tell you what was wrong, or at least it will give you a hint to assist you with troubleshooting. Now you can also see that we have CSV files because we modified the print.prt file to give us CSV files. In the next video, we are going to look at calculating Nash Sutcliffe and p-bias to check the performance of the model.